by introducing myself. I'm Julia, they, them pronouns. I graduated from the MA in 2025 last August, and now I work in academic affairs as a program manager for the MA and the MS, so I'll be working with all of you next year if you come. Joined by two wonderful professors in our MA program, Professors Mingfang, Ting, and Kristina Douglas. I'll read some short bios so you can get to know them, and then we'll ask them some questions, and we can open up the floor to all of you to ask questions. We also have Jacob and Jasmine in the back, who you were introduced to earlier, and they're both current students, so we can answer questions kind of from all angles. I'll start with Mingfang. Mingfang Ting is a professor of climate at the Columbia Climate School and serves as the Vice Dean for Student Affairs and co-director of the Masters of Science in Climate program. Professor Ting's research covers a wide array of topics related to climate variability and change, including weather and climate extremes in a warming world, Asian monsoon systems, Arctic sea ice variability and changes, decadal and multi-decadal climate modes, hydroclimate variability, and the impact of climate change on agriculture and human health. She is a recipient of the NSF Career Award and elected fellow of both the American Geophysical Union and the American Meteorological Society, and was named one of the world's top climate scientists by Reuters in 2021. Professor Ting is also a Climate Core faculty member and teaches the Dynamics of Climate Variability and Change core course. You want to add anything?
No,
good.
Okay. That's good. Thank you.
On to Professor Douglas. Kristina Douglas is an associate professor of climate at the Columbia Climate School and an award-winning archaeologist whose research explores dynamic coevolution of people, land, and seascapes. She is a 2025 MacArthur Fellow and 2021 Carnegie Fellow, also a passionate advocate for interdisciplinary and community-centered science. Her work is deeply grounded in ethical collaborative partnerships with local, indigenous, and descendant communities as equal partners in the co-production of knowledge. Since 2011, she has directed the Marumbe Archaeological Project in southwest Madagascar, examining how communities have adapted to environmental change over time. Professor Douglas is also a Climate Core faculty member and most recently co-taught climate adaptation in the fall.
And this is Kiwi, more importantly. Kiwi is, I'll get his like a bio
For
also.
sure, yeah.
He's a 2.5-year-old German Shepherd dog. He loves playing ball. He loves playing with kids, and most importantly, he comes with me everywhere. So he is my number one TA, number one co-author, TA, and general wonderful support. More than human being. I was about to say person. So this is Kiwi, everybody.
Biggest the star in this room.
We'll have some questions for Kiwi.
Yes, absolutely.
I think we'll start with you, if that's all right. How does your research practice inform the courses you teach?
Well, as you read this long, not too long bio, so my research is mainly in the climate variability and the climate change. What do we mean by that? Climate variability is just like, you see things happen. You sometimes have this year we had a lot of snow here, and in the past 3 years we get very few, like we call snow drought period. And that can be, climate change related, but it can also be just pure climate variability. So that's the kind of thing we're trying to sort of figure out. So that's my research. And the course I teach every fall, the core course, is exactly the same topic. So I think, obviously, they inform each other, research and teaching. In fact, I started teaching now more than 20 years ago. I would say the best part of teaching for me is to sort of gave me new ideas about research. It really helps each other. But this question is more like how my research informs teaching. It's in the same way. So, as an active researcher, I work with my PhD students on research, the students from the program, master students in summer research or BRA, we call it departmental research assistant mode. My research team is really, consists of students, undergraduate as well. So all these research activities are basically constantly informing how I teach the core course, which is, meant to give students a physical, fundamental kind of physical understanding of the climate system, how it works, how variability happens, how climate change can add to the climate variability. So they are so related to each other. So a lot of times I will bring in a lot of examples into the classroom, especially when things like very unusual things happen, like this winter. I currently teach this class, undergraduate class called Climate Systems, and a lot of my students who are like looking at me always like, you know what? I went home today and I was thinking like, oh, I learned about this weather system, how it actually happened. This like bomb cyclone we just talked in class. So a lot of things, we deal with in classroom are what's happening in the real world, and we try to understand them. And one of the advantage over the years, I've been teaching this for a long time, is that we have advanced so much since I was, for example, a PhD student a long time ago. I'm not going to tell you when. So we have really good understanding, solid understanding of how things work, and we also have really good models that can inform us what's happening. For current climate as well as future climate and paleo. In the past, we also look into the past to learn something from that. So yes, it's very integrated kind of approach, and it's not just me. Obviously, you'll hear from Kristina, but also other professors in the program. They are all active researchers or practitioners. They all bring sort of their research or practice into the classroom. So I think that's maybe it's normal, to hear, but I think it is very special to me still in terms of what we are, who we are. And yeah, I'll leave it to Kristina to talk about her wisdom on this.
Thank you, Mingfang. So I teach in the MA program. I teach the adaptation core class in collaboration with other amazing faculty here, Lisa Dale and Jeff Schlegel-Milch. And then I also teach a class called Black Ecologies, which I'm teaching this semester, which looks really at how we have gotten to where we are today, but through the nexus of long-term histories on the African continent and how those histories have shaped the modern world. So we try to understand the world as a toggling between deep time, the present, and then imagining and trying to figure out what we're going to do in the future to solve different challenges we have today and to try to make the planet a more habitable place for everyone. I'm an archaeologist by training, so that means most of my work involves looking at deeper time to understand how everyday people dealt with environmental and climate changes in the past. What I love about archaeology is that it really is a democratizing view of life in the past. We look at everything that people leave behind. So if you think about what you did this morning, almost without even thinking about it, right? You may have gotten out of your bed and changed your clothes. You may have washed your face and brushed your teeth and had breakfast. All of those everyday acts leave behind traces in the material record. And archaeologists, we look through trash, we look through everything that we can to reconstruct what life was like 1,000, 10,000 years ago. Why do we do that? Archaeology, I think, has been popularized as this kind of exotic, let's look for the big palaces, let's look for the big monuments of the past. But really, one of the main reasons to do it is because we can learn from all of this cumulative experience on the planet about how to address challenges today. If you think about your own lives, you benefited from a long chain of transmission of knowledge. You learn from parents, you learn from aunts, uncles, grandparents, you learn from other elders in your environment how to live, how to navigate challenges. That's what humans have always done. And when we add in archaeology, we're basically benefiting from cumulatively, millions of years of human experience on the planet, which includes experience of major changes. What happens when there are major disruptions to sources of food? What happens when weather patterns make certain areas more difficult to live in? What happens when communities go through processes that lead to some having more and wielding more power than others. These are all things that should sound familiar because they have characterized life on this planet for a very long time. So how can we use that information to better understand where we're at today and then make decisions about what we're going to do in the future? And in Black ecologies, more specifically, we're using the framework of Black ecologies, which understands that all of our interactions with our environment, with those around us, all of the relationships that we have are mediated in some way through differences in power, differences in status, differences in experience. So how can we use that to better understand the landscapes we're in today? If we look around ourselves today, this landscape didn't just come about out of nowhere. It's the product of all kinds of interactions. So we try to better understand the contemporary problems and landscapes through that deeper time lens, really drawing from deep time African history and archaeology. And then we try to build a community of thinkers and solution space action to move forward into the future. That was a very long-winded explanation of Black ecologies. The adaptation class, let me just say, is wonderful because it is team taught. So you get perspectives not only from me as an archaeologist and anthropologist, but from other disciplines, which can include political science, development, disaster management, to understand how different disciplines think about making adjustments and changes so that we can do better given the current circumstances that we're under. And I think, just like Mingfang said, research and teaching for me, they go hand in hand. You know, we're so privileged to be able to be in a space of perpetual learning and collective learning, and that means that it enriches my thinking as a researcher, and the thinking and learning I do as a researcher informs the teaching and gives opportunities also for students to be a part of that research process. Julie, you're gonna have to cut me off because honestly, I have a terrible tendency to go on and on, and you all too. I was, cut me off. When I'm becoming long.
I think I'm gonna sit in on Black ecologies.
I know. I was gonna say I would love to take that class.
It's a fun class. It's a fun class.
Yeah. So our second question for both of you again. All of our climate and society courses offer unique access to faculty and academic and professional opportunities. That being said, what kind of interactions do you have with students, either in your courses or as a program leader, and what opportunities do students have to engage in research or practice with you and your colleagues? Start with you, Kristina.
I'll say it just very briefly because I spent too long on the last question. I run the OBT lab, and when I say run, I really mean I facilitate. I facilitate a group of researchers and learners here that connects with a pretty large team of community researchers in Southwest Madagascar. And we explore a lot of questions that you might think of as being, actual sort of science, as we traditionally think, where we're looking at data sets that may be environmental or climate or human related data sets. We have questions, we analyze and interpret those data, and we write papers. And in addition to that, our lab and community partnership is very focused on understanding how we can transform science so that it becomes more inclusive and more centered on community needs. So that work is happening all the time and also provides a lot of opportunities for students to become involved, for example, as co-authors on manuscripts, where we're really trying to develop better methods for collaborative practice. What does that look like? We have weekly lab meetings that involve really trying to practice what we preach, meaning, we collaborate on a weekly basis with a group of 25 community researchers in Madagascar every week. We deal with issues of translation, issues of access to scientific kind of spaces, and it's a wonderful process. So it's something that is open to any student who's interested in becoming a part of that.
Amazing. Every week. Yeah.
Every week.
Yeah. So in terms of the student, I want to just add, a lot of things, Kristina said applies to what I do, in in different contexts, obviously. But I want to start saying the interaction with students really starts in the classroom, of course. And we always tell students to come to, you've heard from the student panel, come to office hours. So that's the first way to get in touch with the instructors. And, I'm very open to talk to students not only about the content that I'm teaching, you on homework, usually people come to for homework questions, but not only that, you can just come chat with the professors, myself included, during office hours all the time. So I gave like 2 hours a week, office hours, dedicated time for just meeting students. So that's one way. The other ways are, through research opportunities. Like Kristina said, her group meeting, this amazing, virtual meeting, everyone can say, oh, I want to sit in and listen. So I have, my research group is based at Lamont Doherty Earth Observatory. So it's a little bit harder, I guess, to access because it is, a little far. I don't know, some of you will be going there. It's amazing place. Your lab is also at Lamont, right? Yeah, so it's a bus ride of like 45 minutes. But it's a regular shuttle that we run here every hour, more or less. And so we have this Friday group meeting. My group and another younger researcher, the two of us, combine our groups together to hold that. In fact, I just had this week's group meeting before. That's why I came to the student panel a little bit late because we had that meeting right before that. And I've invited students. When students come to me, say, I really want to learn what you do. Of course, I could talk to them, but I also invite them, if you want to come and sit in that, group meeting of ours. We call it lab meeting, but we don't always lab. But that's how Lamont people call it. These are lab meetings. And our lab is computer. We just work with the computer. We don't have actually your actual hands-on sort of stuff in the lab. A lot of Lamonters do that. They have actual labs. That some are like clean labs. You have to wear stuff, go in there. But we are very simple. We just laptop connect to the whatever the bigger computer somewhere else. So. But yes, we have those lab meetings for again, I have undergraduates, researchers working with me. I have master students as well as PhD and postdocs, all levels, including the two of us, the researcher in that group. So that's another way people can get involved. And of course, there are research opportunities, as you heard. I've supervised a lot of the students from the program. And I will have probably two students this summer working with me from the MS program. So absolutely, there are a lot of opportunities to get involved, to interact with your professors, and in terms of research. And it's not limited to the people who are teaching also. You can reach out to people who's part of the climate school or even outside of the climate school. And there are, I don't know how many researchers at Lamont. I think usually people say like the order of 500 researchers at Lamont campus, right? It's a lot. Yeah. You can definitely, you will have opportunities announced, for example, in the Wednesday Weekly, but also a lot of opportunities are just through reaching out. You will talk to your advisor, all of you, the students in the program will have an academic advisor. So that's the first contact point in terms of like finding out who you should reach out to if you're interested in a specific topic. And your professors in all the classes, that's another source of information. So I have a lot of students reach out to me to say, I want to work in this area and who should I talk to? Like, Kira, for example, she's working with Yushu and that's one of the person I would recommend if anyone come to me say I'm interested in soil nutrients, how that impacts crops and other vegetation. So that would be the person I would recommend. And if anyone wanted to do archaeology, I would say Kristina would be the person. So there are a lot of information you can get from that, but also searching the website. So many opportunities to interact with people within the Columbia community. And I would say, Columbia, I think, is considered one of the biggest research institute or the university for climate science. I think the number of scientists who are involved in climate research at Columbia, I think it is probably just the biggest. I don't think not even the one of the biggest. So you have a huge network here that you can see.
I'll just add, in terms of that network extends. Thank you, Christopher. Christopher is an angel. I really injured my back earlier this week, and so this is a heating pad to help me be able to move more. Thank you, Christopher.
And she's an angel, just to be fair. When I came to Admitted Students Day last year, after I talked to Professor Douglas, I was like, I'm going here. And I told her, even if she taught muffler repair, I'd be like, okay, I guess I'm taking muffler.
One of the amazing things about climate work at Columbia is that you have folks in every discipline imaginable thinking about and working on climate. So you might think atmospheric science, and of course there's a huge research community at Lamont and in the Department of Earth and Environmental Sciences. But if you look at the business school, if you look at in climate finance, if you look at Teachers College, there's a whole program in climate education, along with amazing opportunities to go and listen to speaker series with speakers from all over the world. It really is a hub. I think in every single field, you will find some representation of people working on climate-related issues. In the arts as well, there's a climate humanities program for undergraduates. So it really is kind of a multidisciplinary approach to climate work here.
That's a very good point. Yes. Yeah. It's not only climate science when I say climate researchers.
Big network.
I will also add, just from a student perspective, that I think one thing that's really special about this program is a lot of the professors are currently working in the field outside of Columbia too. So it really gives you a lot of access to people who are working in local government or NGOs or working in the private sector, whatever you're interested in. The professors who are teaching those classes are also practicing and still working in those fields, which I think is really unique and special to get that experience. Being able to meet people who have full careers in the field and being able to learn from them and be involved in their current work, as both of you mentioned. That was a real pull for me. I know. I'll ask you both one more question and then we can keep going, or we'll open up to all of you if you have questions. No shortage of questions here. But this final question is kind of a two-parter. Can you share a moment in your career that reaffirmed your commitment to climate and environmental science, and also what helps you stay hopeful about our ability to navigate climate change?
Yeah, I can get started on this, and again, Kristina probably has a lot more, wiser things to say about these topics. Yeah, I started sort of the moment thing. It's a little hard to say which exact moment. I was trained as a meteorologist in my undergraduate major is actually called meteorology, which is really atmospheric science. I never really did any forecasting. Meteorology, it seems like you're trained to do meteorological forecast, but it was more physics-based, sort of atmospheric science. And then I came to Princeton in the 80s. Again, you know how old I am for a PhD, for my PhD study. And that was the time. It's sort of like, the El Nino Southern Oscillation. We had come to this reckoning that we actually can predict it well. So it's really a huge moment for climate research. And I was at this laboratory called the Geophysical Fluid Dynamics Laboratory it's a NOAA lab at Princeton. So that's obviously is a hub for developing models, numerical models, simulating climate. And so obviously my research is also linked to that, but it was more of this El Nino Southern Oscillation, which by the way, was the prediction of that is started from here at the Lamont Observatory, Professor Mark King and his then postdoc Steve Zibiak, the King-Zibiak model. If once you study, in the dynamics, you'll probably hear these names. and they were the pioneers of predicting El Nino Southern Oscillation. The reason it's so important and so influential is because El Nino cycle has really global impact. It can cause a drought in some region, wildfire in in Indonesia when it's an El Nino, and a drought in India, impacting crops. So all kinds of impact. Not El Nino itself in the tropical Pacific, but it's not just there. And in the U.S., the flooding in California, Southern California, during El Nino, and then drought during La Nina. So it can billions and billions of dollars are impacted, are lost because of these kind of cycle. So the moment we know, we can actually predict them. That's really is amazing. So I started doing my PhD research in that area, which obviously it's variability. That's kind of like almost people say climate variability, the first thing they think is ENSO, El Nino Southern Oscillation. It's till now, we're still working on understanding ENSO, even though we do know a lot about it already. So that's kind of my moment. I wasn't sure I'm gonna do climate per se, and maybe I will, do numerical simulation of the clouds, or something, more focused on atmosphere side. But my PhD dissertation was doing sea surface temperature globally, how that impacts climate. In terms of the second question, I think, no question, like you all learned from the student panel who are so eloquent, so talking about all these things they feel. Obviously we're all worried about this climate challenge we're facing, right? The huge problem associated with it. Temperatures are continuously rising, global temperature, and CO2 levels are not slowing down. The COVID, there was a dip coming down because of COVID, everything stopped. But quickly we just resume everything afterwards, and then we're continuously climbing. So there are a lot of challenges, but I think what keeps me sort of hopeful. I want to emphasize the hopeful part. I really feel like we are in a very good time right now. Just looking at how much we know about the climate system, I think the skeptics, there are still climate skeptics out there, but it's less and less, just because the science is so solid now. And the models are doing such an incredible job of simulating. And I think you mentioned, people, or someone else mentioned people involved in IPCC. Our scientists are involved in writing the IPCC report based on these amazing models, and we'll also use in dynamics a lot. And so we have very good understanding of what's going to happen, and we can actually share that with everyone, and which is also the students from this program. You are all kind of learning how to communicate that to the public. And secondly, it's more importantly, maybe that's where I'm listening to the student panel. I was they're all talking about these favorite electives. They're all talking about climate tech, energy, renewable energy courses. That's really where I see the hope. I think we are doing really well in our, energy transition, renewable energy development. I was actually not being political or anything, but the right in this country, right, the MAGA people, they actually are now very much into solar power energy. Washington Post had an article not long ago. Katie Miller, Stephen Miller's wife, she's being very much, a podcast, very influential person, is saying, we should definitely, devote to solar panel. Obviously, their motivation is not for climate, right? It's more for things like, how do we power our, AI centers, right? It's impossible to come up with all these extra energy. So they're like, let's use solar. Solar's all there, out there. Let's use it. And also because they're cheaper now, right? And you look at the energy price. Renewable energy used to be so expensive. Now it's no longer that expensive. So I'm looking at more from the not so much of rely on people's conscious about we have to care about the environment, but rather just economically. We have those tools now, and we're constantly developing new ones. So making it better and better. So that to me is a big thing. No matter, what the politicians, whatever the partisan, kind of politics in this country is, it's not going to stop people from using it because it's more economical, making sense, and saving money for everyone. We have a war going on right now. This is the energy that's available to us, right? You don't have to rely on fossil fuel exclusively. And I think more and more people realize that, or coal, plants. And also in Asia, our dean just went with an Asian trip in the winter in January. She came back, it's like the biggest thing she saw there, China, Singapore, Hong Kong, all these regions, just like we are way behind here in the US. And they are doing so much in terms of renewable energy, as well as, electrical vehicle. And I go back to China because my mother still lives in China. So I go back every summer, and I'm just so amazed seeing how many electric cars are running on the road. And it's like constantly increasing, because in China, it's interesting. If you go there, they have like green plate versus blue plates. So the green plates are electric cars, and the blue plates are these fuel cars. And you count them, it's like more than a third, definitely, but probably now can be approaching half. And you talk to the taxi driver, and they're all driving electric cars. And why are you driving electric cars? And they're like, I can't make any money if I drive, a oil, fueled cars. So it's gasoline fueled cars. I mean, it's just a reality. It's not so much of, these taxi drivers love, green energy or green, environment, just because that's the only way they can make money. So I think these kind of things are really making me hopeful. I think we are going into it in this country as well. Maybe a little less in the beginning, but eventually we'll get there. Sorry, this time it's me.
Very, very passionate, I think, call for hope. And I'll start with the first part of the question, just to say that I feel like I had no interest in climate. When I started graduate school, I didn't think I was interested in it, thought about it. I was really interested, first and foremost, in understanding how perceptions of communities south of the Sahara, perceptions specifically by European thinkers and writers in the early modern period, had shaped colonial missions in Africa. And then I became interested, as sort of part of that, in these monumental constructions out of earthen mounds that span the entire Sahelian belt from Western Africa all the way to Eastern Africa. They're massive, and they would have required, and this will connect to why I'm hopeful, huge amounts of collective action. And how do you do that? And in the absence, in some cases, of evidence of, highly centralized state operations to make these constructions happen, how did this happen? And what role did these massive mounds of earth play across this landscape? And because they were understudied, I thought, well, this would be a wonderful dissertation project. It seems very definable because I can go to one of these mounds maybe, and I can spend my dissertation fieldwork excavating and documenting this. But then in the second year of my PhD, I read some articles about island colonization. And these are debates that occur across the world, whether you're talking about the colonization of islands in the Pacific, and by colonization meaning when people first settle these islands, or islands off the coast of Africa, including Madagascar. I started to hear different arguments for why some parts of the world were settled at earlier times and some places later, and then why island environments were so supposedly vulnerable to human arrival, and how human arrival kind of changed the trajectory of many islands, causing extinctions of animals and plants, reshaping vegetation, scapes, etc. And part of that debate brought me back to where I grew up, which is Madagascar. I moved around a lot, but I spent a lot of my childhood in Madagascar. And this is the fourth largest island in the world, and for some reason has been a hotbed of island archaeology debate with relatively limited evidence to support some of the arguments that were being made. So, I'm a graduate student and I'm hearing these narratives about how people arrived on Madagascar very late in human history, which is surprising because it's so close to the African continent, relatively speaking, and that as soon as people arrive, they catalyze this wave of animal extinctions and a complete transformation of this island environment. And I was hearing echoes of what I heard as a child growing up, which is that local communities of fishers, farmers, herders on Madagascar were one of the key concerns in terms of preserving this precious kind of biodiverse set of island environments. So I started to feel very uncomfortable with this connection between the archaeological past, conservation of Madagascar in the present day, and I thought, I want to explore this question a little bit more. And it wasn't long before my advisor said, I'm working on a special issue in the African Archaeological Review, which is a big journal in the field of Africanist archaeology, on climate and archaeology in African contexts. Can you write a review paper on this intersection between climate and archaeology in Madagascar? And I said yes because my advisor asked me to do it. But I thought to myself, I have no idea what I'm talking about or where I'm going to start with this. And that was one of the most difficult endeavors academically I have ever embarked on, because I had no background in climate science. And having to read through all of these papers, in atmospheric science, papers in geochemistry, and try to synthesize what the debate was about, and what did we know, what did we not know, what was the quality and resolution of the data sets that we had available, and then how do you put that into conversation with the archaeological record. It was excruciatingly hard. It took me a really long time to work on this paper. Halfway through the project, I reached out to a climate scientist who works on coral records and reconstructing really high resolution paleoclimate records from tropical corals, Jens Zinke, who today remains a great collaborator of mine. And by some grace, he said, sure, he'd love to work on this. He had cored some corals in Southwest Madagascar. And through a very kind of thoughtful process of mentorship, he and I worked on this paper. And by the end of the paper, I realized that, I was going to be studying this intersection of climate, environment, people responding to and shaping environment and climate. And so that launched it, but it was painful. It was really, really painful. I realized from then on that actually climate had always been in the backdrop of some of the things I had been thinking about, including, for example, being amazed by the tremendous collective action you can see in deep time as people were dealing with climatic change and extreme weather events. I learned about, because I had several colleagues who worked on the north coast of Peru, going back 5,000 to 7,000 years, you see communities on the north coast of Peru in these valley systems making sort of hydrological engineering adjustments to embankments and figuring out how best to both protect themselves against major flooding events, but also use those flooding events to their advantage for farming and for harvesting marine products. So I learned that if you look all over the world, people have been dealing with climate in a variety of ways. That speaks to my second, the answer to the second question is what makes me hopeful. I mentioned this earlier, that we do have collectively a huge amount of experience of different environmental and climatic conditions. But more importantly, what distinguishes climate change today from climate change in deep time is that today climate change has been driven by human inequality, differences in consumption, difference in the impact of climate today. So climate change not only is driven by that inequality, but it impacts inequality. It exacerbates inequality today. So dealing with climate change means that we have to figure out what are those elements of being in community and being minded, having a mindfulness about collective action and community action that can bring out the best of what we can do, that we see in deep time, right? And deal with the things that have driven climate change in the modern era, inequality. How do we address these things? So I became very interested in that and also very hopeful because of all the examples I see in the past, but also in the present, of when people can actually form strong community ties and then work together to solve really complex challenges. I became really hopeful that we actually do have the capacity to be able to adapt in ways that are more just, and also to be able to mitigate, future change by focusing on things like inequality and focusing on the sort of bottom-up solutions. Communities who are in particular places and have been for many generations have the best understanding of how climate change is impacting them, and also need to be at the center of developing solutions to address change. So I'm very hopeful about that process. And I think that we are, as Mingfang said, I think we are in a very good time right now where there's a huge awareness about the importance of community, which I would say extends to us right here, right now. And as you're considering, your next steps, anywhere you go, anywhere we are, we have the opportunity to build community ties and to think about what that means in terms of reciprocity, in terms of really getting to know one another and understanding, that we have some different needs, but maybe there are places we can meet in the middle. I think we have to practice that in every space that we are in, because we can scale out from there and we can transform different sectors, different industries, and make them more focused on like community building and collective action, because that has characterized the most successful adaptations to climate change in our human history over 100,000 years that we've been in our sort of more cognitive and behaviorally modern form. So that makes me very hopeful.
We have just a few minutes left. I don't know if Kiwi has anything to add. But I think we have no, he seems pretty sleepy, so I think we'll save the questions for these two. If anyone has any really quick, I think we could take one or two quick fire questions, and then we'll all be around to answer questions. I think your hand was up first. Go ahead.
Thank you. Hi, I'm Durga. I'm so grateful to have met through the school, and I would love to know what are the opportunities to engage in service in the community, especially in Harlem, and are there ways, particularly around like community gardens and building collaborative forms of community justice, and how is the school doing that already, or do you see ways for us to build that together?
That's a great question. One of the most active kind of networks is the Environmental Justice Action. Is it collective? It's EGAC. Collaborative. Thank you. And they have a lot of partnerships throughout New York City and the surrounding areas, linking up sort of basic research in climate, in policy, in economics, with active, locally based environmental justice organizations. They have a wonderful newsletter, and if you Google Jacqueline Klopp and Paul Gallet, you can probably get on their newsletter already and see what are some of the initiatives that they're involved in. I know also that Sheila Foster, who's a professor here in the climate school, has many active partnerships within the city. She's trained in law, and so she's looking at really the intersection of climate and law and the policies that make certain communities less able to adapt and cope with climate equitably. And in addition to that, because we are situated in Manhattanville here, we have engaged with organizations like We Act and Harlem Grown. I know a lot of students who have gone and volunteered and who have interned with those organizations. I think this is something that we want to encourage more and more. And to the point about community building, we all, as a community, I think should take it upon ourselves to try to build and enhance that network in any way possible. In the Black Ecologies class, we're trying to do that and create some partnerships also with local businesses in the community. You know, what are the Black-owned and other minority-led businesses in Harlem that we can support and we can interface with through our work at the Climate School. So I think the possibilities for that kind of work are limitless. There's already a good start, but we need more dedicated folks who are willing to go out there and build those connections and who want to find ways to leverage, you know, what are we doing here at the Climate School that might be of benefit to a local organization and vice versa? You know, how can we really develop those partnerships? So it'd be wonderful to continue to expand that work.
So I just want to add quickly, we also have an impact lab within the climate school, and led by Sandra Goldmark and Joanna Lavecco, and both of them are, you know, obviously sort of like overseeing this kind of different project. Some of them are looking at local impact of climate change, so the community involvement. So you can also, you know, check out the website about our impact lab.
I think we have time for one more really quick question and then we'll wrap up. I think so. Your hand was up first.
So hi, my name's Gail. It's so nice to meet you, Professor Douglas. And Professor Ting, I think I met you last night at the next year event. So my question, I think this might apply to a lot of people here, since this is like an interdisciplinary major. I'm sure a lot of people, including myself, are like interested in many different aspects of climate. So do you have any advice or tips on like how to narrow your focus, especially when we're thinking about like what courses we want to enroll in and how to shape our degrees?
I would say, you know, the program is sort of like arranged in this way that in the fall you get to take all the core courses, not all of it, you know, many of the core courses. Dynamics, for example, you know, I have students taking the class, they would never thought about going into science research, and afterwards they're like, I want to do this, you know. And you know, as Kristina said, you know, she's part of that team teaching adaptation. And there are, you know, so many different angles in that class that you might find something that resonates with you, and also, you know, mitigation is another aspect of that. And we have the justice, you know, Sheila Foster, you know, Kristina mentioned, she's teaching climate justice, another core course. So all of these interdisciplinary core already kind of position you sort of like getting a very good overview of the climate research, climate science from multiple angles. So that'll certainly, hopefully, you know, give you some kind of like, you'll find where you feel the most at home and wanted to, you know, most passionate about. Yeah, and I would say that would be the, you know, one thing, and obviously talk to a lot of people. Yeah.
I can add just quickly that I also think because climate is such a rapidly evolving area of work in many different sectors, there are profiles of, you know, what somebody could do in a given sector that haven't really yet been fully developed. I think that's one of the most exciting, but also can be a little bit daunting aspects of going into the sort of broader field of climate. But what I would say is that you can start mapping out skill sets, people whose profiles speak to you, could be in a range of different sectors, but you see people doing certain types of work. And so you can start to sort of map out who are those folks, who are organizations, or what are organizations that are working in a way that you find interesting, and mapping it out kind of systematically. Some people, I always recommend do it in the way that is easiest for you to organize. Some people are very visual and want to, make a big mind map. Some people want to keep it in an Excel spreadsheet. But start doing that now so that you can start to pick up on some of the patterns of both what speaks to you, like where do you want to go with your degree and with the training that you would get here, and who most resembles that. And you may end up finding that there's somebody who does exactly what speaks to you, and you want to kind of do that, and that can allow you to then map that out. How do you get to what they're doing? What are internships that might be good, or what are different skills that you might need? But you also might find through that mapping process that you want to occupy kind of a new space. And then you can work with faculty, you can work with peers and members of staff to build the kind of network and plan for getting there. What are the skills you might need? What are the networking opportunities you might need? So I'd start doing that. It's kind of like a systematic vision board, but I think important in the climate space because things are moving so quickly and changing so quickly.
I know we are short of time, but I just want to quickly, when you say the mapping out, we have an excellent career team here. So you absolutely should talk to them, when you some ideas like Kristina suggested, then talk to them, what are the potential opportunities out there.
I'll just wrap up by adding it's a fast year. The
Yes,
year goes by
very
fast, but it's really the launching point for your career in climate, and so you don't need to have an answer in August when you graduate. You have the rest of your career and the rest of your life to figure out where you fit in. And like Kristina mentioned, the climate field is new. There might be jobs that don't even exist yet that you will find 20 years down the line. And I think that it's about what you can pull from this degree to figure that out.